我们非常感谢荣幸的请到我们美国国家宇航局首席知识官 Roger 先生给我们讲知识管理如何造就 NASA 的文化。这是我们呢组织隐形技能管理全球智库大师课堂讲座第17场，总共呢我们计划呢要开50场，我们会邀请全球在组织隐形技能管理领域全球的这帮大师来给大家去分享。今天我们做是第17场，在我们开讲之前，让我们来首先认识一下我们今天的演讲嘉宾。大家可能看到我们的演讲嘉宾Roger 先生也是刚刚退休，他是非常资深的宇航局的前首席知识官，他领导过 NASA 的知识管理工作，确保 NASA 的员工能够在完成任务所必须的所有的关键知识。因为你知道航天这件事跟很多其他事不一样，如果有任何一点闪失和错误的话，都可能导致巨大的损失甚至灾难。所以在这种情况下，我们来学习一下他们是如何去做好知识管理的，尤其是隐形知识的管理。OK， 当然了，我们的 Roger 先生在 NASA 来工作了总共38年，2021年刚刚退休。他把他的过去的经验里面曾经写过2本书，一本书叫精益知识管理 NASA 如何实施适用的知识管理项目，这是他的第1本。那第2本他是写了当毕业的时候学习才刚刚开始，主要是给很多的STEM 专业的学生以及专业人士的一个课堂，如果给他们一些经验，给他们一些借鉴，他所写的2本书。当然他其他的还写了很多的博客，很多其他的文章，到时候呢我们在课后也会结束以后呢，大家跟我们的客服联系，你可以获得相关的这些链接，但有些链接我们可能会把它翻译成中文给到大家，能够帮助大家去理解，好吧 ？OK， 好，这是我们的认识的今天晚上的演讲嘉宾。那本次讲座是由 Mr.Roger 导师学院以及组织隐形技能管理全球智库联合主办。那 Mr.Roger 它是一家总部位于比利时布鲁塞尔的全球化导师服务咨询公司，它呢业务遍布全球6大洲35国家和地区。那他所有提供的导师技术培训均获得欧洲导师教练协会的认证。那么 Mr.Roger 注册在上海的中欧合资企业，他是在2019年10月份首次把欧洲导师教练技术正式引入中国。那么组织隐形技能全球智库呢，它是一家注册在比利时布鲁塞尔的非营利性国际智库，它旨在推组织隐形技能管理在全社会的运用，推动人类的高效率学习啊。OK， our distinguished speaker, Mr.Roger, was the wonderful speech. OK. Now, so 如果所有人呢讲课的 PPT 感兴趣，你需要获得 PPT 的话，你可以扫码入群，我们就把 PPT 呢都发给你啊。如果你有其他的一些资料呢，再给大家去共享啊。好，那然后呢？后面呢，我就把这个我们的演讲嘉宾 ，OK， 好 ，OK。
Thank you so much for that introduction. I appreciate that, and it's really an honor and my pleasure to be here today in front of this group to talk about 2 subjects that I have a great deal of fondness for. One is the National Aeronautics and Space Administration, NASA, and also knowledge management. A little bit about me before we begin. My first degree was in liberal arts. I majored in history. I never was able to really find a satisfying career, so I decided to start all over, and I started as an apprentice mechanic at NASA. I also went to 10 years of night school to earn both an undergraduate degree in engineering and a master's degree in engineering. I worked as a technician and later as an engineer on the space shuttle program. In 2005, I became involved with training, and I moved to NASA headquarters in the Washington, D.C. area. In 2015, I was selected as the NASA Chief Knowledge Officer, and then I retired in 2021. And since retiring, I wrote 2 books. The first one we'll talk a little bit about today is called Lean Knowledge Management, How NASA Implemented a Practical KM Program. And my second book is called When Graduation's Over, Learning Begins, Lessons for STEM Students and Professionals, and that's going to be published this month, as a matter of fact. Talk a little bit about NASA today. NASA has approximately 18,000 civil servants. These are people, federal employees that work directly for the agency. The average age is about 46, so it's an aging workforce, and that's important to know for knowledge management, because one of the key efforts that knowledge management attempts to do is to transfer tacit knowledge from very experienced people to a new generation of employees. So knowledge management is very important at NASA, and it's considered to be a critical tool. Put this in context, during the Apollo years at NASA, the average age was 28. And right now for SpaceX, a new company that's been very successful in the launch business, the average age is about 29. NASA also has approximately 60,000 contractors across the country. And also the fiscal year 23 budget for NASA is $25.4 billion. Put that in context, that represents less than 1/2% of the United States federal budget. Back in the Apollo heydays around 1966, the NASA budget was 4.4% of the federal budget. So it's a much bigger emphasis was put on NASA in comparison to the federal budget back in the Apollo days. NASA today has been very successful. The International Space Station has been a spectacular engineering achievement, and that's probably why so few people hear about it today. It's also one of the most costly and the most difficult programs ever made by man. Its current price is somewhere in the $100 billion range. The modules were assembled completely in low Earth orbit, and some people have said that it's comparable to the giant pyramids in Egypt, and as well as the Great Wall of China, as far as a large program or project for a generation of people. JWST was launched on an Ariane 5 rocket last year. It's currently parked at Lagrange Point 2, which is about 1 million miles from Earth. If something fails or goes wrong, it'll be too far for astronauts to travel to fix it. There's a lot of risk, as well as a lot of potential scientific knowledge from this program. And it's been just a tremendously complex project, but it's also returned some really stunning images, which I'm sure you've seen in the news. The SLS, the Space Launch System, this was first launched in November of 2022. It was an unmanned rendezvous with the moon. That was going to be followed in 2024 with a manned launch that will also rendezvous the moon. And then 2025, SLS is going to send astronauts back to the moon, where they're going to land on the surface. And it's also in the future, SLS is expected to be used to send astronauts to Mars. The Commercial Crew Program originated about a decade ago, and it's a partnership between NASA and SpaceX and NASA and Boeing. The United States government has decided it's time to turn over low Earth orbit to commercial companies, and for NASA to concentrate on exploring the solar system. Both SpaceX and Boeing have developed capsules that can launch from Cape Canaveral rather, in Florida, and dock at the International Space Station. NASA has also done extensive planetary research on Mars. NASA has sent 4 rovers, and the Chinese space program currently has a rover on the surface of Mars. NASA has also been involved in aeronautics and is working on a supersonic aircraft that has better fuel and noise capabilities. NASA has been involved in a wide variety of major programs. It has a very large portfolio of scientific and engineering projects, and I highly recommend you take a look at nasa.gov to kind of see all the different programs and projects that NASA has been involved with. But now I want to talk a little bit about the past and how NASA learned critical lessons from human tragedies and how it changed its culture and became a stronger and a safer space agency. NASA has had difficulties in the past. The Apollo 1 killed 3 crew members in 1967 and almost ended the Apollo program and the US's desire to go back to the moon. The Hubble Space Telescope launched in 1999 with a faulty mirror due to manufacturing and quality issues. It was only saved by sending a space shuttle up near where it was orbiting and astronauts had to replace various fixtures and components on the space telescope to get it to work correctly. NASA has also had some trouble with probes going to Mars. They lost the Mars Climate Orbiter in 1998, along with the Mars Polar Lander in 1999. And then there was, of course, Challenger in 1986, and then the Columbia tragedy in 2003. I think everybody remembers where they were when they first heard of the Space Shuttle Challenger explosion. NASA managers had decided to launch the shuttle on a record cold morning in Florida, despite objections from the NASA and contractor engineers. The result was a failure of one of the O-rings on the solid rocket motor that caused flames to escape and eventually ignite the main fuel tank. America lost 7 extraordinary men and women on that cold January morning. One of them was Crystal McCullough. She was the teacher in space. January 28th was actually the coldest morning recorded up to that day in Florida. It was procedures for NASA to launch always required at least 4.5 degrees Celsius for launch. This day it was negative 8 degrees Celsius. But NASA management decided to launch despite their own regulations about launch guidelines, and despite the objections of numerous NASA engineers. One of the engineers was actually told to take off your engineering hat and put on your management hat, and change their mind from not launching to launching to go ahead with the management decision, despite the safety for the vehicle and for the astronauts involved. We all know that brittle O-rings on the solid rocket motor failed, causing catastrophic failure that morning. President Reagan at the time appointed the Rogers Commission, and they came up with a report that said that yes, of course, the O-rings were the problem, but this was a bigger problem at NASA, and was an accident rooted in history. It was a decision-making process that led to the launch of Challenger and the destruction of Challenger. Every time there's a failure with hardware, there's always, personal feelings with it, but these are magnified when human beings and human lives are involved. Bob Eberling was one of those contractor engineers that was trying to convince NASA management not to launch that day. The fact that he was unable to prevent the launch is something that haunted him the rest of his life. And he made a comment to a news reporter years later, and he said, "I think that was one of the mistakes God made. He shouldn't have picked me for that job. Next time I talk to him, I'm going to ask him, why me? You picked a loser." NASA dealt with this tragedy in pretty much an inappropriate way if you're involved with knowledge management. They recovered the hardware and the debris, and they stored it into a abandoned missile site that's on the Cape Canaveral side of Florida, and then they covered it with a huge cement block so that it was inaccessible. But 7 years later, NASA endured another tragedy when the Space Shuttle Columbia disintegrated above the skies of Texas during re-entry. Again, the world lost 7 just incredible human beings. In the video, you can see where the foam hits the leading edge, causing a hole in the wing. And then upon re-entry, plasma formed in that wing, and the vehicle was destroyed. The accident report noted that NASA management had been aware for years of problems with foam coming off the main fuel tank during liftoff. And in this case, a large chunk had hit the left wing, the most vulnerable point, causing a massive hole. Another presidential commission was appointed, this time by President George W. Bush, and they wrote a blistering report condemning NASA management and the decision process used to launch Columbia. Managers were fired and reassigned. This time NASA was told to make changes, and they did. President Bush actually ended the space shuttle program. And then NASA implemented something that's called technical authority and dissenting opinion. And this is a program where every project team member has a responsibility to speak up. Every manager has a responsibility to listen, and if necessary, independent subject matter experts will be brought into the program or project to determine which is correct if the project team member has a valid complaint or a valid issue. NASA learned a very painful lesson after these tragedies, but to be honest with you, I'm very proud to be a part of an organization because I think we became stronger, and we became an organization that was willing to learn from the past and learn from our past mistakes. In 2011, the Aerospace Safety Advisory Panel, the ASAP, this is a group that's appointed by Congress, and their role is to advise NASA management on how to manage some of the large programs and projects. Most of the members of the ASAP committee are distinguished people retired from the aerospace industry, or even retired NASA astronauts. In 2011, they insisted that NASA appoint a chief knowledge officer to enable the agency to learn from the past. They also stated that NASA is very good at gathering knowledge, but not good at disseminating it to its employees. The ASAP panel tasked NASA with finding a way to share critical knowledge with its employees. And also what NASA did when they appointed a chief knowledge officer is they gave it organizational respect, because they put the chief knowledge officer, who was myself at the time, into the office of the chief engineer. And an organization like NASA, which is composed of almost all engineers, all technical people, the office of the chief engineer is one of the highest offices within the agency. And to place the knowledge management and chief knowledge officer in that office showed NASA employees the importance that NASA management has for not only knowledge management, but also for training. So we had to kind of devise an approach to meet the ASAP panel's demands. And I convened my team, and I think our approach was really a three-step. First, we had to define who our audience was. NASA, as every organization, has silos of different responsibilities and different people. You have finance, and NASA, you have diplomatic people, you have contracting people, and IT people, and things like that. So, and each one of these areas deserves its own knowledge management program. But for what we were focusing on is from an engineering standpoint, we needed to focus on the NASA technical workforce. These are the men and women, the engineers, the technicians, the scientists at NASA. These are the boots on the ground, the people that really have to get things done on programs and projects. And only once that you can define who your audience, then you can go and define what critical knowledge is for that audience. And we were able to do this now. And what we decided, our only purpose for our KM program was to make their job easier, make the men and women on the front lines that were building and designing the hardware, working on the space shuttle program, working on any of these major programs on the space station, to make sure that our role is to make sure that make their job easier. And the other thing we needed to do was to make it simple, keep it simple. We needed to avoid academic jargon. The NASA technical workforce is interested in getting their jobs done and doing it correctly and properly. They're not interested in the kind of KM research that's done in academia. That kind of research is very critical, and it's very important to move knowledge management forward. But for our specific audience, we had to make sure that what we were giving them was the results of knowledge management at NASA, and kind of moving them away from the kind of the more academic views of knowledge management, where knowledge management should go. And the other important thing we did to keep it simple was we developed a one-stop shop website, apple.nasa.gov. This is available to anybody in the world to go check it out. This is a website where rather than have our people in our technical workforce, our audience, going to a variety of different websites to get information, to find out where lessons learned databases were, to review case studies, to see what kind of courses they can take. Everything was combined into a one-stop shop website, and I encourage you to visit it. And the other third important thing we did for knowledge sharing was we combined knowledge management with the agency training. NASA had a very successful agency training program, and it was attended by almost everybody on a program or project team attended the courses. And what we wanted to do is make sure that we combine knowledge management with agency training, because the agency training was an excellent conduit to get the knowledge management information out to our audience. And then we came to the thing where the crossroads where we had to define explicit versus tacit knowledge at NASA for our technical workforce. And Dr. Clifford Motto, who's also spoken to from the GO-TKM, Global Organizational Tacit Knowledge Management Group, I think he came up with an excellent definition of explicit knowledge. And it is knowledge that is transferable through media, such as procedures, databases, rules, and regulations. And for us, that's our lessons learned database. And then Robert M. Grant, I think it gives an excellent definition of what tacit knowledge is. And it's expertise and knowledge within an organization, primarily located within the brains of employees, that cannot easily be transferred. And this is tacit knowledge management is so critical from getting from the people that are in the know, the people that have the knowledge, the critical knowledge within your organization, to get it to the newer people, the newer hires, and then younger people moving into your organization. So what we had to decide is, how can we effectively disseminate tacit knowledge at NASA? What we needed to do is to develop knowledge events that resonate with our audience, something that the technical workforce would be interested in, and the technical workforce would want to learn and want to attend. So we developed coursework, and our coursework were always emphasizing learning from the past. We talked about Shuttle, we talked about Hubble, we talked about the Columbia tragedy and the Challenger tragedy. We made sure that we talked about information and case studies that were really relevant. We also talked about critical thinking skills. You know, sometimes you have to look beyond the easy answer. You have to go beyond that and dig deeper to find out root cause analysis. And also we talked about cognitive bias and decision making. And this is you know, an area, a big area of study and an important area, especially on program and project teams, where people sometimes go into a meeting already convinced that they know the answer, or they have a subtle or a internal bias that they don't even really realize at the time that they've already made up their mind before they've discussed something. So we just want to make sure that everybody on a program and project team is aware of that bias, that internal bias that they may have, so that they can kind of go into a meeting and come up with a more collective idea of what the program, what the project is, and what the problems may be and how to solve those. We also looked at doing video interviews with leadership and practitioners. And this was talking to NASA leadership and NASA program managers on major programs and projects. And we basically asked them, you know, what was your biggest mistake and how did you solve it? And it worked two ways. It not only from a technical standpoint, it helped an audience understand what the problems were, but it also helped change a kind of culture where people weren't afraid to talk about their mistakes, and that people realized that the only learning that really happens is from making a mistake and gaining from it and learning knowledge from it, so the mistake doesn't happen again. We also developed, every 2 weeks, we developed a podcast where we interview program and project managers and talk about knowledge management and other issues that are important with any program or project team for a technical audience. And the podcasts were particularly important and popular with our younger workforce. And it was a new venue that we could use to reach out to our workforce. And then we also developed a leadership and a mentorship program, something that I think every organization, especially an organization that has a growing aging workforce, mentorship programs are critical. And then also, to utilizing tacit knowledge management resources. Apollo 1, Challenger, and Columbia. We want to make sure everybody at NASA never forgets about these. And what we did in the past, as I mentioned, with the Challenger tragedy, NASA management at that time, back in 1986, took the debris that was found and they buried it so that it could never be seen again. What we wanted to do, and what the NASA management after Challenger, was to make sure that didn't happen again. And so what they did is they brought that, all the recovered debris from the Columbia accident. It was brought to what's called the Columbia Room at the Kennedy Space Center. And it's a gigantic room which any NASA employee can visit. You can still see the landing gear where hydraulic fluid is still dripping from the cylinders. You can see some of the tires. You can see the windows that the astronauts looked out as they were coming into deorbit. It's really a moving experience. It's an experience that I can only compare to like attending a funeral, because you can even see some of the personal effects that the astronauts took on board with them that are on a little table as you walk in. It really hits home, and it brings home. And the meaning of the Columbia Room is for our NASA employees to make them realize how important their job is, because people's lives are at stake on many of the decisions they make and many of the hardware they design and build. Also, January 26th each year is called a Day of Remembrance at NASA. Every program and project team is supposed to stop and take a collective moment together to talk about Columbia, Challenger, to talk about their own programs and projects and how they can improve, learn from the past and improve their programs and projects. And what we specifically did with knowledge management at NASA is we developed the Columbia Agency Tour. And this was because not everybody can visit the Columbia Room. Not everybody gets a chance. We have 10 field centers throughout the country. Not everybody gets a chance to go to the Kennedy Space Center in Florida. So we decided that we were going to bring the Columbia message to each of the centers. And we devised the Columbia Agency Tour. And it's to have a more positive theme. It's of course to talk about the tragedy, but more importantly, I think from a KM standpoint, it's what can be learned from the Columbia tragedy. And at these forums, we invite former flight controllers, men and women that were there at their computers, and they're at the landing site waiting for the Columbia to come home, and it never did. And just to get their feelings of how they felt at that moment when they realized that a tragedy had happened. And also we bring some of the Columbia artifacts and put them on display. And again, what we make sure is that during this forum that we stress technical authority and dissenting opinion process to make sure everybody at NASA understands that they have a voice in the decision-making process. I think, when you talk about knowledge management, changing a culture, knowledge management isn't going to do it itself, but it's going to be definitely a factor and a tool that management can use to change a culture. And what I think NASA, what we did at NASA with knowledge management is we helped nurture an environment of transparency and openness. We talked about my best failure, and this is a willingness to talk about failures, where a failure is an opportunity to learn rather than an opportunity to be punished. KM supports technical authority and dissenting opinion. Again, these are critical components that every NASA employee has to understand, that they have a role and they have a responsibility in the safety of not only people, but also the hardware that they design and build. And I think, finally, when you talk about failure, there's a dichotomy. And there's a dichotomy at NASA, and I think there's a dichotomy at every organization when you talk about failure. Gene Kranz, one of the very famous NASA flight controllers, very well respected within the agency, at one time said, failure is not an option. But then later he also said, there is no achievement without risk. Well, you're always going to have to balance between failure and risk and success and risk. So for an organization, this is a problem. But I think for NASA, or for knowledge management, this is actually an opportunity. Of course, you want to avoid failure. And the whole idea of knowledge management is to avoid failure. But sometimes failure is going to happen. And if it does happen, you have to learn from it. And after all, isn't that what knowledge management is all about? Learning from the past, learn in order so you don't create the same problem again. You want to avoid failure, but you can't be afraid of failure. It's unfortunately, but sometimes it's a necessary part of the process. and you have to take advantage of that. And it's not really failing if you actually learn from it, your organization learns from it. You become a stronger, more effective, more efficient organization. And that's what knowledge management is all about. And with that, if there's any questions, I'd be happy to try to answer them as best I can. I also wanted to give my contact information. If anybody has any, wants to follow up on anything I said or wants to continue the discussion, my email address is below. And once again, I said I'll be happy to try to answer any questions that you may have. With that, thank you very much.
Now let's enter the Q&A part. And 大家有什么问题的话，现在可以提问。Hi Roger, we have some questions from the audience, and I put some of them in the chat box. The first one, according to your experience, what are the most effective knowledge management activities at NASA?
That's a very good question. I think case studies are one. I think a well-written case study can that makes the reader really puts them in another person's shoes when it comes to like decision making and things like that. So it's real easy to sit back and second guess a decision or second guess a design or something like that. But in a well-written case study where somebody explains the whole background to a situation and why a manager or why a program manager, project manager made a certain decision. I think in an area like that where the person gets a more fuller understanding of the situation and how it developed, I think that's a key way to, or as far as effective knowledge management. Coursework is another one. I think integrating knowledge management, integrating case studies, and for us, integrating some of the KM procedures and processes that we had throughout NASA into our coursework was critical.
好的，第一个问题呢是，就是在 NASA 它的知识管理活动中，比如说哪些知识管理活动是最有效的？然后 Roger 先生他就提到了一个，就是关于将知识管理与案例研究结合的这么一个，比如说课程培训这样的案例分享。因为通过这样的活动是希望大家能够设身处地站在别人的立场去考虑问题，特别是涉及到比如说这个项目中他的项目经理、他的管理层，他去如何做这样的决策。因为通过分享过去的案例研究，然后我们了解到当时的这个项目管理者他们是如何对这个项目然后做这样的相应的决策，我们了解到这个相应的背景，然后再考虑到今天的情况，我们可以做一个对比分析，然后我们如何从过去的这些经验教训中，然后去学习。然后主要呢就是我们要通过这些过去的案例研究，然后能设身处地的了解当时的情境，然后再回想到现在的情形。然后这种方式呢，对于在组织内进行知识管理是非常有效的。好，大家还有没有什么其他的问题？ Roger's second question in the chat box.
What triggered me to make the decision to change my study path from history to engineering, I think it was a practical one. History is still my first love. I love history and I love engineering, but history is something that's always fascinated me. But it's not easy to make a living studying history. You can either teach or work at a museum or something like that, but there aren't that many jobs available. And that's why I decided to make a complete career change and go into engineering. Engineering is something that always interested me. I was always taking things apart as a kid and trying to figure out how they worked. The math was a little difficult for me, but I decided to start all over and start from the beginning and start a new career. And it took 10 years of night school to do it, but in the end, it was worth it. And everything worked out for me perfectly at NASA because when I became the chief knowledge officer, chief knowledge officer and knowledge management really deals with history. And I was dealing with history and dealing with engineering at the same time. So it just, everything just kind of blended real nice together.
第二个问题呢，就是讲了 Roger 先生他最开始的时候，因为他是学历史学的，后来呢，他就是转到了这个工程的专业。然后我们观众朋友的问题是如何，是什么驱使他，然后从这个历史学转到了这个工程的方向。那 Roger 先生他的回答是，其实历史呢这个问题其实是比较实际的，其实很多人也相信有相同的感受，因为历史呢其实一直都是他就是第一喜爱的这个专业，他是非常喜欢的。但是考虑到现实情况，就是这个专业毕业以后，就是就业问题确实是一个麻烦，然后就是在可能生活方面就是带来一些困难。因为历史专业毕业的话，大家的就业选择就比较有限，可能去当老师，或者说当可能音乐方向的这类工作，然后就是对他的生活带来影响。然后后来呢，他除了历史专业，他其实对工程专业也是非常喜欢的。然后这个也是让他下了很大的决心，就是从历史转到了工程这样的一个方向。但事实证明呢，这样他是值得的。虽然这个过程中其实是也比较艰难的，因为他也付出了很多，比如他花了有10年的时间，就上了夜校，然后拿下了这个工程学位的这个学士以及硕士学位。那在 NASA 工作以后，特别是他当了首席知识官以后，然后他发现，就是因为他在 NASA 的知识管理工作，就像我们刚才 Roger 先生的演讲里也提到，就很多都涉及到就是历史方面的问题，我们很多都是从历史中学习。那这个对于他而言也是将历史，就是他的喜欢的2个专业，历史和工程相结合。那对他来说这也是非常值得的。好，我们还有没有其他的问题？
Hi, Roger. This is Michelle, and thank you for sharing the great practice on knowledge management and link to culture. I have a question regarding technology authority and the dissenting opinion process. Could you please share something more? Because I think NASA is a huge organization. My specific question is, from the title, the process is not an easy one. How long did NASA take to make the process settled? Because you said it's not nurturing an environment of openness and transparency. Learn from the past. So I think, what type of the typical challenge did you face when you apply this process?
That's a great question. And dissenting opinion and technical authority are 2 of the key elements that knowledge management was able to help transform NASA's culture. In the past, I think NASA kind of evolved from the military, that military standpoint of take your orders from above, don't question them, and move forward. And I think at the beginning, during the Apollo program, that type of management was necessary because we had a goal to get to the moon by the end of the decade, 10 years, and starting from scratch. And I think you had to take kind of a military approach like that. But I think later, as NASA evolved into a more of an engineering and a research organization, that type of management attitude had some difficulties, and those difficulties, I think, were shown during the Challenger and during that Columbia program. So it was changing NASA's culture is something I think that after Challenger, when NASA was told to change its culture and it failed to do so, but after Columbia, it was Congress and the president demanded that NASA change, and they demanded that we implement a program where NASA employees have a voice in the decision making, and that managers have to listen to that type of from the expertise from the engineers. And that's what dissenting opinion is all about. That anybody on a project team, no matter what their role on a project team, they have a responsibility, not just an opportunity to speak up, but they have a responsibility if they see something wrong to bring it to management attention. And if their immediate supervisor or manager still doesn't, if they can't come to an agreement, NASA can bring in subject matter experts to discuss it. And these are people that are, they're not employed or they're not paid for by the program or project. They're absolutely independent. And they can come into it any you know, when there's a discussion, particularly when it involves human life and human safety. They're available to come into a program and project and make a decision to make sure, you know, that the dissenting opinion was either correct or incorrect, or somehow to solve the problem. And I think one of the key things to understand is that knowledge management, and certainly at NASA, knowledge management did not change NASA's culture. Knowledge management was a tool that helped managers change the culture. And knowledge management became a two-way street between management and employees, and also employees and managers to speak to each other, talk to each other through coursework and through forums, and just to develop a more transparent and open environment.
Yeah, thank you very much.
好，谢谢 Michelle。第三个问题是，我们刚才 Roger 先生在他的这个演讲中提到了一个程序，就是 NASA 实施的叫做技术权威与异议意见程序。然后 Michelle 他的问题是，就是这个程序，然后当时在 NASA 是花了多久的时间，然后落地的？因为 NASA 就是它从过去的那样一种文化，然后渐渐的就是转变到这样另一种开放透明的文化，那这个过程呢，一定会遇到很多的挑战。那在这个过程当中 ，NASA 它遇到了哪些挑战？然后 Roger 先生的回答是，因为知识管理它对于就是转变 NASA 的文化是起到就是至关作用的。其实，在 NASA 的过去，因为过去的时候呢，当时也是就是处于军事化管理，然后一切呢都是以就管理层就是上司他司令的意见为准，然后下面呢只需要执行，然后上述的命令就可以。但是经过就是一系列研究发现以后，就是发现这过程中出现了很多的问题，特别是在 NASA 它经历了一次一次的悲剧以后，特别是像那个哥伦比亚号和挑战9号那个航天飞机失事以后，然后导致就是 NASA 的管理层他们不得不面临一个态度的变化，而且当时就是美国国会也下令，就是让 NASA 它必须改变它以前的文化。然后在那个时候呢 ，NASA 就是开始了它的这个文化转变之路，然后它实施了这个技术权威与异议意见程序。在这样的程序之下，它是规定就是 NASA 所有的雇员他都有就是这个发言权，就不只是管理层。那而每一个管理者他都有责任去听就是来自工程师们、技术人们的意见。那在项目团队里呢，也是就大家都有责任就是发表自己的意见，而且也必须就是有一个能力，就是能够预见就是错误的能力。然后呢，特别是而且还要引起这个管理层的注意。那同时在就是对于对应的项目呢，也引入一个就是专家，然后就是邀请比如说外部的独立的专家，然后也邀请他们进来，就是帮到大家就看到问题、解决问题。然后不只是一些就是可能是工程方面的专家，也涉及到比如说就是人类人文权利、人类安全这方面的专家呢，也都会邀请进来进入这个项目，然后大家一起对这个项目的安全各方面的问题负责。因为知识管理它是不能帮助 NASA 改变它的文化的，但是它可以是管理层用来转变这个文化的一个工具。然后在 NASA 它这个知识管理就是也是有就是涉及到就是两方面的，一方面呢是就是针对我们管理层的，然后管理层他也有意见，就是有意见去听取这个员工的意见，然后在员工呢他也有责任，然后表达自己的意见，然后大家呢就是相互讨论，相互一起解决问题，这样就形成了一个这样开放透明的 NASA 的新的文化。Roger, the fourth question in the chat box.
Tacit knowledge, especially professional knowledge, is usually difficult to understand. How can you keep it simple to the public? Would you like to share an interesting story about it? Tacit knowledge, you know, that's the most difficult knowledge to try to retain within an organization, because it's, you know, it's something that's one or two or several employees have learned over the years, and they've been there for 20, 25 years, and they understand a program and a process as individuals. And trying to, especially, I think mentorship is important, to try to get some of these folks that have been within an organization for a long time and own this tacit knowledge, to get them to be able to share it with somebody younger, somebody moving up, because sooner or later somebody's going to retire, this person's going to retire and move on. So you have to be able to transform that tacit knowledge from the older, more experienced employee to a younger employee. And I think mentorship's an excellent way. At NASA, we developed a leadership program where for 1 week, and the leadership program probably had maybe between about a dozen attendees into the leadership program. And these are really highly skilled young people that we felt that were had a lot of potential to become managers someday. And we bring them into headquarters, and we try to assign them to a very high upper level manager for a week, 10 days, 2 weeks, just to spend each day going to the meetings together, you know, participating, listening, to trying to get a good feel for what it's like to be an upper level manager. And the nice thing about mentorship is it works two ways, because we have a younger employee that's learning from an older employee, and also the older employee also learns from a younger employee, that learns what motivates new hires, what motivates a new generation of NASA employees. So I think that's a excellent way to transfer tacit knowledge, and especially when it comes to for leadership roles.
我们第4个问题是说，隐性知识是通常是非常难以理解的，然后如何就是能够让它简单的就传达给他的受众。然后 Roger 先生能不能分享一个比较有趣的故事？Roger 先生他的回答是，知识管理它确实是应该说是最难以就是能够留存下来和分享的这个知识，就隐性是非常难以去留存和转移。那因为隐性知识，它很多情况下都是我们非常有经验的人，他通过很多年的可能工作中或者各个项目中积累的经验，然后才形成的，可能这个耗时可能有20多年，甚至30多年的时间，甚至更久。那对于组织而言呢，其实要去特别在这个年长的员工、资深的员工要离开的时候，要把他们的这个隐性知识留下来，确实是非常难的。在 NASA 呢，他举个例子 ，NASA 有一个领导力的项目，然后就是针对那些就是高潜力的人才，然后他们就是有这个潜力成为领导者，然后专门针对他们做了一个项目，就是这个项目大概有10多个人参与，然后就是让他们来到在总部，然后大概就是每个人都会给他们就是分配就是相应的就是管理人员、管理层的人，然后大概让他们就是年轻的员工，然后跟我们这些管理人员就在一起，就一起参会、一起工作，然后大概一起待上1周或者就10天甚至2周的时间，然后就是在这个过程当中让他们去感受就是管理层他们是如何做各项工作的。那这种方式呢，也是一种非常互惠的方式，即使一方面年轻人他可以向资深的这些有经验的员工，然后学到很多东西，然后同时呢，这些年长的员工他们也能向这些年轻人学习到很多东西。所以这个过程呢，是不管对年轻人来说，还是资深的年长的人来说，都是非常有益的。那对年轻人来说呢，这也是一个就是非常好的学习机会，也是 NASA 一直在做的一个事情。好，大家还有其他的问题吗？Roger, I think we can stop here for Q&A. Thank you very much for your sharing and the great answers.
Thank you.
Yeah, Fisher is now in another meeting. He will send you an email later and express his appreciation for you.
Thank you.
Thank you very much. And I will now share the slides about the feedback from the audience.
Thank you, Icy, and thanks for doing the translation. You did a wonderful job. It's been wonderful working with you.
Thank you. And 如果大家还有其他的问题的话，我们可以就是事后收集起来，然后可以就是一起问到 Roger 先生。Roger, there may be asked questions from the audience. Perhaps we will collect some of them and ask you through the email.
Certainly.
Thank you. 好，现在呢，我们非常感谢就是大家花时间参加我们今天的讲座，然后我们也希望得到大家的反馈。那这个在这个屏幕右下方呢，是我们那个反馈的二维码，然后大家可以扫这个下方的二维码，然后留下大家对今天讲座的意见。好，在这里我们顺便也做一下，就是下期的我们组织运行技能管理全球智库讲座的这个预告。下一位嘉宾是来自澳大利亚的 Arthur 先生，他是澳大利亚知识协会的会长，也是皇家墨尔本理工大学的客座教授。然后同时呢，他也是 Intelligent Answers 这家公司的首席执行官。他要分享的主题是隐性知识在适应中演变。那时间呢是下周2月21号的下午4点到5点。那感兴趣的朋友可以扫右方的二维码，然后报名参加我们这次讲座。最后呢，我们跟大家分享一下，就是在今年的9月3号到5号，我们即将在瑞士达沃斯举办的第2届组织隐性技能管理论坛。那详情的话，大家可以点击，就是可以输入右下方的这个我们的官方网址，然后查看更多的动态，是 3w.GO-TKM.org。好，以上就是我们今天的讲座。好，非常感谢大家的参与。Roger, that's all for today's webinar. Once again, thank you very much for your sharing.
Thank you. It's been my pleasure.